Okay, well, thank you everyone for coming, especially our U of R people. We are super happy to have you for this. I think we're going to learn a lot from each other this meeting. I wanted to start by just sharing an article I found. This was talking about these, they're basically like wind kites to harness electricity. These are being developed in the Netherlands. From what I understand from reading this article, basically this diagram in the middle on the bottom, basically as these kites go up, it pulls this cable with it, and that generates electricity. And if I remember correctly from reading the article, they're trying to have these like ready for purchasing by like 2021. I just thought it was really interesting because I've never really seen anything like this. So yeah, if anyone wants to see this article afterwards, let me know and I can send the link. So couple RIT things I want to go over first. We've got our e-board election results, and then we will have our 3x5s. So congratulations to Peter, who's going to be our vice president, our treasurer, who is Shreya, and our new event coordinator, who is Eli. So congratulations to you guys. This does mean that we need a follow-up election for our communications chair position. Basically, the way this is going to work from now through next Tuesday, nominations are going to be open. The week after that, the nominees accept or decline their position. The next week, nominees will present, and then election voting is open. So after this meeting, RIT people, you're going to see in the Slack a poll for nominations. Okay, so this is the order that we are trying to do these 3x5s. I wanted to have RIT and U of R kind of going back and forth for the most part. Okay, so are there any questions before we just get into it? Okay, then first up we are going to have, let me preface this by saying we have a whole bunch of presentations. I am going to be timing them to make sure that we can fit everyone in. So it's going to be 6 minutes, which is 5 minutes of presentation, about a minute of questions and conversations afterwards, and hopefully we'll have time at the very end for any other conversations that people want to have. Okay. So with that being said, first up we have RIT Haiti Arborloo.
Hey guys, I'm John. I'm a project leader for Haiti Arborloo along with Apsara. She's helping me out this semester because I am very busy, so she's been taking the reins, but I will be presenting today. So we've been working on this for roughly, I think 3 or 4 semesters. I've only been on it for 2. And it was originally a RIT capstone project that was eventually, I guess, abandoned. So we picked it up and we're hoping to finish it this semester. So why the Arborloo? So it's really for rural Haiti where there's no really running water or like electricity. There's a lot of natural disasters, lack of proper sanitation, access to toilet, lack of industrial resources, deforestation. So we're really trying to like aim for something that they can build there and are can be easily taken down. So then when storms do come, that their infrastructure isn't completely wiped out. Especially making lasting infrastructure there is really, really expensive. So if something like this can be mobile, it will really help them. The sustainability aspect of this is the biochar base. So what the biochar is, it's basically a certain type of concrete mix, which they should be able to make there by using like ash and stuff like that. I'm not huge into what all the concrete stuff does, but that's what we have. Could you go to the next slide? So because it was a capstone project prior to, they went down to Haiti and they had got some feedback from the people there. And one of the feedbacks was that the door was originally like a shower curtain. They really didn't like that. So we're trying to implement a new type of door where it's more of like a latch, or like it slides onto the next pole, as you can see in the diagram there. So that's like where we're aiming for this semester. We're also, we basically have it built this semester, which is what we were aiming for. We have all the sides and the poles built in there, and the roof is going to be put on this weekend. Yeah, if you go to the next slide, I think there's a picture of it up. Yeah, so that's what we have at the moment. And because we're just testing it, we're not actually going to put it into the ground. So we got buckets of dirt to stand it up. So we will be testing that very soon, very shortly. So like, and we're gonna like structure test it too, make sure that like it can't just be pushed down by like, you know, Rochester wind or anything like that, because the winds there are going to be a lot stronger, especially during storms. But the objective is to be able to take it apart. So as you see, the top poles that go horizontal, they are able to pop off along with the roof. So then we can just roll all of this up into one piece, as you can see in the bottom right picture. The base is being tested. We have several concrete molds, or like different like combinations, formulas, ingredients being tested right now, and hopefully they will be done very soon. And then it is on to our last step, is making an instruction manual for the people of Haiti. And we're gonna have to translate that, I believe, to French is what they speak. But we're gonna aim to do it a more visual instruction manual than a written one, because I think it'll be easier on both sides. That is the basis of our project. And does anybody have any questions?
Can you talk about, I know somewhat about this project because I was in like the first iteration of it. But can you talk about what the materials you use are going to kind of convert to in Haiti?
Sure. So if you go back to the first slide, I think it was, we're trying to get it so that they can use bamboo instead of the PVC pipe, because they can't use PVC pipe. We used PVC pipe because ordering bamboo here is really, really expensive, and we didn't know that when we were going into it. So for the test, we're using PVC pipe because it's similar properties. It's like roughly the same size. So when it's up, it'll be the same. We're hoping for them to just be able to like find and adapt things along their way. So like, as you can see, they use like the thatching siding, which could work. You know, they could use that. If they have tarps there, they can use tarps. They can use cloth even. I mean, sure, it might get wet with the cloth, but like it'll dry in the wind, you know. It's not that big of a deal. You can also like waterproof certain things with things like beeswax, and I'm sure they know other waterproofing techniques and things that we could do some research into. I talked about the concrete base is just biochar, just ash and different type of mix to make it into the concrete. And then for the roof, we're hoping for something like that piece of scrap metal you see up there, or they could just layer bamboo with like palm leaves or something on top. So we're hoping this will be successful. Some of the challenges we face is not really having a direct line of contact with Haiti or people in Haiti, like what they really want. So we've only been given a little bit of feedback, and so we're trying to do the most of what they've given us. So
Cool. Thank you, John. For reference, that was like almost exactly 6 minutes. So it goes pretty speedy. Awesome. And we definitely will have time to talk about this afterwards. So if anyone else has questions, just save them and we should have time at the end. Next up is improving urban infrastructure.
Hi, so I'm Avery, and I'm one of the project leaders for improving urban infrastructure. The other project leader is Haritha, who is not here at the moment. Yeah, so if you want to go to the next slide. Our project is mostly based on the fact that since U of R is in the city, public transportation is a big part of how students get around outside of the campus. So we were looking at problems that we could perhaps improve there. So we looked at the shuttles and we kind of decided that they were quite inefficient. And because of that inefficiency, a lot of students are often left waiting in the cold during the winter months in bus shelters that aren't heated or really protected from the elements while they wait for the buses to come. So we decided to create a twofold project where we're going to focus on improving the bus routes and improving the comfort of the bus shelters by installing some sort of heating into them. Yes, please, could you? Yeah, so our goals were to create a survey we could send out to the students of U of R and get their input on what they think about the bus routes, how much they use them, where they go, and try to figure out what sort of routes get the most use and how we can improve their efficiency, where we can reduce stops that aren't used, put stops in that need to be used, figure out where more buses should be allocated. And then hopefully after that is all, we've got all that data, we'll formulate the plan and then present it to the transportation department for U of R. And our second phase was to find green solutions to heating the bus shelters. So we're going to look at the shelters around the campus. There are a few on campus that we can easily look at, and we'll use those as a model for how to build up as we expand outwards through the bus routes. And currently our plan is to put in a solar water heating system where we'll run pipes filled with water through the bus shelters that will give off heat through convection or conduction. I'm not sure which one. And it'll be heated by a solar water heater on the roof of the bus shelter using solar panels or other green methods. And hopefully we will eventually be able to join with the biofuels project in running a biodiesel powered bus that would be able to drive along a new route that we would create with the students of the U of R community that best serves the community where they need to go. So that's sort of the end of this the presentation. Does anyone have any questions? We're sort of a new project and we only just started up a few weeks ago, so it's still in its infancy, but I'll try to answer any questions anyone might have.
What kind of questions are you planning on asking in the survey?
So currently we're looking on first, we're gonna look at class year and if you're on campus or not to sort of categorize where riders are. Then we're going to ask about what routes are ridden the most, how often they're ridden, just like how often you are riding the bus, like where you're going, what stops you're taking, the purpose of your trips. And then we'll ask questions like, what do you think, what routes do you think aren't, how do I say this? What stops do you think aren't really used? Or would you like see as placed somewhere else? And what stops do you want to see added to the routes? sort of like that. I hope that sort of answers your question.
Yeah, it does.
I'm curious why you decided to choose water heating as your like to heat the bus shelters.
We haven't actually finalized that yet. We're still researching possible solutions. Water heating just seems to be the most likely solution we'll choose because it's simple to operate, it's cheap, and it can be effective when there's like, I don't know how to explain that. Because we do have to look at if it's going to be in a public place, we have to like worry about, would anyone try to like steal it if we put like a solar panel on the roof? So if we have like a solar water heater, that's essentially just a box with water going through it that just uses the sun's energy naturally. So that's easy to maintain, easy to set up, and would still provide heat to the bus shelter without more expensive materials. Although we're also looking at other options that do use things such as solar panels, like we looked at infrared heating as a possible option, although we're probably not going to go with that. And we also looked at perhaps using like a green burning fuel like the biodiesel as a heat source.
Cool. Awesome. Well, thank you. Next up, we have Insolist.
All right, hello everybody. My name is Jimmy and I'm the project lead of InsolNest. That's the name I came up with for our sustainable installation product. So first of all, let's go like top down here. You see a bunch of pictures of different animals and animal structures, and as well as fungus. So we are biomimetically inspired. So biomimicry is a big part of this project. So we looked at different thermoregulation mechanisms in different animals. For example, the walrus, it's got blubber, so it's limited conduction. The cross-section of the polar bear hair, it's hollow, so it's using some sort of an aero insulation mechanism, which is what we're using as well. That bee-looking creature, that's the Arctic yellow jacket. Again, they use air layers around their colonies. And the shiny ant, that's the Sahara silver ant. They are limiting radiation, literally reflecting sunlight so that they're not fried by the sun. The top right picture, that is called the mycelium. It's the root structure of mushrooms. Think of it as mushrooms fibers. They're not actual mushrooms. Okay, so the middle diagram, you call it, shows how our product sort of, I don't know, maybe it's a product. Our product sort of solves the question, right? That the problem statement, the problem statement has to do with how current construction materials used in insulation are not sustainable. They're not biodegradable. They're toxic, obviously, because a lot of times you have to wear PPE during installation. So we're using biomaterials. We're getting that efficient use of material through the use of air pockets, so that we can cut down at least 33% of the materials. That's going to be low cost. So those air pockets are going to be engineered. We found this article about how that works, and through simulations in SolidWorks, we've able to show that adding an air pocket to just a regular construction material does work. It does make it better in terms of insulation. So below that are some of the other designs that we've added. All right, next slide. All right, so for this semester, so this project has been going on for, this is the third semester. We're using Zoom not only for our meetings, but also customer interviews. We're starting to do that. We just finished our second customer interview yesterday. I'll go again from top down. So the white mold that you're seeing there is our mold that our fabrication lead made. That's going to be the shape of our test samples. So 2 weeks ago or a week ago, we made our first 2 samples out of wet wood shavings, flour, water, and of course the mycelium spawns. That has been growing. The top right picture shows the growing process of the sort of the fiber that it's coming out as. That has actually hit a roadblock because we're seeing some bacteria growth, which is not good. It's kind of like a recipe, you still sort of have to adjust the ingredients and the different things we have to take care of in terms of like sanitation. There are several research areas that we're looking at. One of our biggest problems is definitely longevity and treatment. So actually going back to Haiti, where you have structures being destroyed every once in a while, we might be able to solve that more easily because we are using biodegradable materials as insulation or construction materials. Yeah, and then fireproofing, that's a must. If you're building a house, and some other ones, cost, environmental impact, of course. And then the lower right shows just how adding a layer of air improves the insulation ability of your material. You guys can't see the probe there, so I'm probably not going to talk about it. It basically shows that heat travels slower in our experimental one with the air layer. Okay, third slide, I'm going over. All right, so our next steps, again, we finished our second customer interview. We're waiting for sample 1 and 2. They're not going well. We're going to do them again. Testing of physical properties is what we're trying to do by the end of the semester, at least 1 sample. So a sample is something you see on the top there on there's 3 strips of mycelium. They're quite like EVA foams, to be honest, but they're, again, completely biodegradable. So we're going to test them based on their tensile strength, their flexibility, and of course their thermal resistance. And more simulations are underway. So that's there's the list of our team members. Shout out or whatever. Yeah. Can find the space in the first slide. Any questions?
I do want to keep us moving because that was exactly 6 minutes. I swear to like within 2 seconds. So if there are questions, there should be time for that afterwards, but I do want to keep moving. But thank you, Jimmy.
Yep.
Next up, we have biofuel synthesis.
Okay, so I'm Theo, and I'm not the project leader of this. Project leader is Tracy, and she cannot be here, so I'm going to go over what we're doing to make some biofuel. So we can go to the next slide. So we started this project last year, actually. We had a deal with the Downing Hall to take some of their used vegetable oil, which are typically paid to be disposed of in landfills, which is a very hefty process, and a lot of it is consumed, a lot of it is wasted. So our program was to introduce a greener alternative to the typical petroleum diesel that you would find in engines. And basically the process is we're gonna use a transesterification process, and given the acidity of the waste vegetable oil, there's a lot of fatty acids in it, so we have to neutralize it with potassium hydroxide. And we're also going to be extracting glycerin from the reaction. I'm going to talk about this later, but this is another very useful product. Numerous applications can be used with glycerin. And in the end, we're also going to mix the biodiesel with standard petroleum. If you have pure biodiesel in an engine, that creates issues of its own, and it's not really effective to have like greater than 20% biodiesel, and that's also indicated as B, and then the percentage. So 20% would be B20. And once we're actually finished with the production, we're hoping to test it on farm equipment, and as Avery was talking about before, the school buses. We have a known standard that we're going to be testing it with. And so glycerin is also one of our byproducts. And some of the applications, just to name a few, are artificial sweeteners. They can be used in medicine, and a big application is their presence in soap. But before doing this, before we actually have a pure product, we're going to have to remove the methanol. The methanol is a component of the biodiesel production. But glycerin with methanol is not safe, so extracting the methanol is necessary before ending up with a final glycerin product.
Awesome, thank you, Thea. I was actually so how do you remove that methanol? Is it like a tricky process, or is it a relatively easy thing?
Methanol is just through typical chemical extractions. I do have a more detailed document that goes through the steps, but it's nothing tricky. It's all done with different densities of layers, so it's not especially difficult.
And then is that the only is that the only byproduct? Is there anything else that you have to be careful about disposing of?
Well, there's potassium hydroxide, which we add to that, and something that we need to be careful with. A lot of materials that do require precaution and safety. But as far as there's not another byproduct that we have to worry about purifying or disposing of.
Does anyone else have any other questions?
In the future, would you bring this to would you have a customer where they would go around to certain kitchens and take what you were saying with the vegetable oil and collect it from everywhere?
Yeah, absolutely. I think that if this project goes well, we continue on course, I think it's definitely something that other clubs at different schools or even within U of R should follow. Just given the massive production of oil and usage of oil that may go to waste. I think there's this is a great application and a great way to reduce the waste of it.
Yeah, definitely.
Can you use that methanol too? I'm a mechanical engineer, so all of this is very over my head, but can you use that methanol as well, so you're essentially creating a zero waste cycle?
I haven't really thought about that, but I think that if you extract the methanol, you can use it for later times.
Awesome. Any other questions? Okay. Thank you, Theo. We are going to move on to our water filtration team.
So hey everyone, I'm John. I'm the project leader for water filtration. We're focusing in Haiti. We're partnering with a company called TAM Ceramics, who is trying to create a water filtration system that can be used in houses in the third world countries that will hopefully cost less than $10 and last for upwards of 10 years. And can be built with the common materials. Next slide.
Okay, so I'm going to talk a bit about this project. We're, like Jonathan said, partnered with TAM Ceramics to create a water filter. They've given us the filter material, which is infuse microscopic silver particles that will go into the area where water is filtered. The water filter should be designed for a household setting assembly, and then the picture to the right is basically one of the samples of what they did. We're hoping to kind of use it as a model and improve upon it. And then the desired water flow for this filter is about 2 liters per hour.
Okay, my name's Christian, by the way. So basically where we're at right now and like what we're going to be doing with this, we have a basic design that's kind of what you've seen to the right. That's just kind of like a small CAD drawing. Right now we're kind of still in the research stage, kind of moving into a fabrication, like making a prototype kind of thing. And we're still kind of figuring out how we're going to like contain the granulated ceramic media like within the, like as a filter in the either PVC pipe or bamboo or whatever we're going to use. And so, yeah, we're thinking maybe using like a coffee filter or really anything to hold the material up. And yeah, once we figure out all of that, we'll start making a prototype and hopefully get to more of a design process in the coming weeks.
Awesome, thank you guys. Does anyone have any questions?
I do have a question. So, so is $10 the total price for this construction, or is that going to be just the filter media? I'm a bit curious about that.
So the plan is that the filter media will be like either given out at a very cheap price by TAM Ceramics when they go on, if they like help another organization go on humanitarian trips or something. And then the idea is the structural part is hopefully going to be around $10. The filter media is kind of separate from that cost estimate.
So in the same way that the Arbor Loop team has to think about what materials are available in Haiti, do you guys have to think about that as well? Or is it kind of like, is there some assumption that you're going to be able to get these materials in Haiti?
Yeah, that was one of the main questions. So our customer, Reed Harvey, said that many third world countries have access to a PVC pipe like equivalent or kind of equivalent. It doesn't quite have the structural integrity, but for just holding a powder, it will do. He said that bamboo could work. And then it kind of, he also said that TAM Ceramics understands that different areas are going to have different resources. So our plan is to give potters or just anyone a generic design, and then provide like options or suggestions for what they can build their specific filter assembly with.
Awesome. Any other questions? All right, cool. Thank you guys. Next up, we have the U of R Solar Decathlon Design Challenge team.
Sorry, I've kept myself muted for a bit. Yeah, so hi, my name is Leonid Solodov. I am a project member for the Solar Decathlon Design Challenge project. The project leader, Kai Anvi, was not able to make to this meeting, so I will be presenting in his stead, I guess. So the Solar Decathlon Design Challenge is an intercollegiate competition focused around the development of a design for a building powered by renewable energy. Each team chooses a division, which is another word for, or a word used in this competition for a building type. The building types for this competition are listed on the bottom in the bottom right list. Currently, our team is looking at the urban single-family housing division, as it is the division for a potential design partner, which I will come back to design partners and on the next slide. So not yet. So from each design competes with other designs from the same division in 10 contests, which are listed on the left. Okay, now we can switch. Okay, so teams then travel to an event at the National Renewable Energy Laboratory in Golden, Colorado. The top 10 teams in each division, based on an earlier deliverable in February, are able to present in front of industry leaders in person, while non-finalists present posters at the same event. Now back to design partners. So design partners are organizations, are when organizations provide an initial design for a group to approve on, and provide, I believe, 25 advising hours to help with this improvement. So, and additionally, as not all schools have the same curriculum, they provide a 3-module mini course to bring some of the schools that do not have an architecture or a building science curriculum. So they require people that do not have that in their curriculum to complete the 3-module mini course. And the last thing that I would like to mention is that projects teams are not limited to being just from one university. So in future years, as this is an annual competition, there are opportunities for collaboration between universities. So that's all I have to say. If there are any questions.
So how far are you guys into the actual design process?
So we're currently in the very early stages. The entry into the competition was we entered the competition formally by filling out the application for it just a couple of days ago. So that's where we are with our design. Our design is very early. We're going to be meeting with a design partner next week, I believe, that design partner is Habitat for Humanity, and their division type is urban single family housing, and that's why we are leading to that division. And aside from that, the first deliverable, which is technically an optional deliverable, but it's just a basic pitch on December 1st. So we'll have we should have a decent idea of what our design will be by early December.
I wanted to go back just to look at these. So you're talking about doing the urban single family housing?
Yes.
Okay. I mean, perfect place for it. Yeah, that you'll definitely be able to work within the community for that. That'll be great.
True.
All right, does anyone else have any other questions? All right, awesome. Well, thank you. So next up we have Red Creek.
Okay, I'm going to be presenting this one again. The project leader, Kylie, she has class right now, so she's not able to make it. But yeah, basically, you can go to the next slide. What it's about is we're trying to prevent runoff from the Genesee River, basically, from Red Creek. So it runs through Rochester, and we don't I mean, if you don't already know, runoff is kind of bad because, you know, like pollutants can get into the water and it can harm sea life, it can harm fish life, like anything that lives in the water basically. And so we're trying to prevent that. Our main focus right now is K-Lot, which is, the people from University of Rochester probably don't know, but I mean, there's a map, so people at RIT can probably figure out where K-Lot is. That's our main focus, and it runs, as you can see, like directly next to and parallel to like the Red Creek. And that's kind of one of the main lots on campus. So our goal is just to kind of prevent runoff from occurring through a bunch of different solutions. And right now we're just kind of in the research stage. So you can go to the next slide. So some of our research options, we kind of have it narrowed down to 3, but we're still open. Retrofitted porous pavement, that's kind of, you'll see more of that on the next slide. We don't have many pictures right now because we're still in the research stage. We don't have any actual developmental stuff yet, but it would be nice there because like the porous pavement would be nice because it would fix the runoff really well, and water can just seep through. The only downside of that would be you need pretty, not constant maintenance, but you have to make sure the pores don't get clogged up with dirt, salt, all that kind of stuff. Another option is eco swales or bio swales. That's what you see to the right. Those are a lot easier to implement, and they're a little bit more, they cost less probably. We're still kind of looking into that, but yeah, basically that would also fix the runoff, but it would have to be also maintained a lot more. And we're still kind of looking into that. Another option would be road salt alternatives, because that's one of the pollutants that could go into the water. And obviously, since Rochester is a lot harsher in the winters and much more snowy, that would be another good option in the winters, just finding different options for road salt. So yeah, if you can go to the next slide. Right now, we're basically just trying to research each thing more thoroughly, finding the costs, finding the ups and downs of each one, seeing how long they'd take to implement, because obviously we want to get this implemented as soon as possible. And once we finish our research stage, then we'll try and do some tests and try to write some proposals to RIT and just kind of see what their thoughts are. But yeah, basically that's all I really have for that. Like I said, I'm pretty new to this. I'm only a first year, but if you have any big questions that I can't answer, I can direct you to the project leader, Kylie.
Yeah, as a little bit of, I was the project leader for this last semester. I bet U of R has them as well, but examples of eco swales. So if you guys know, in front of Perkins, that whole strip by the road, ton of eco swales there. They're not necessarily as pretty. They have similar things like around, I believe around like Gleason Circle to the, like towards the Policini Center. Yeah, I think eco swales is definitely the way to go with this. Have you gone and looked at that little strip of between the stream and the parking lot?
Not yet. We're still kind of in that process though.
Mm-hmm. Yeah, I was just gonna say, because it's relatively narrow. I think it's I measured it. I think it's like 4.5 feet.
Mm-hmm.
But I think there's definitely a chance to implement an eco swale there. I also think it would be cool to have maybe a physical barrier towards the road, because a lot of trash ends up in there. Anyone who lived in Perkins when those bikes came out, we'll know that a bike ended up in that stream because someone thought it would be funny to throw it in there. But that's an extreme example. But
Yeah, for sure.
Would because there's only 4 feet of clearance between the road and the creek, wouldn't that be hard to implement something like a bioswale? Because wouldn't the construction of it cause pollutants as well?
Yeah, I mean, we're still kind of looking into that. I guess, yeah, that's kind of where it's tough. You kind of have to find the best of both worlds. Like, what's the cheapest option? What's the easiest thing to implement? And like, what is the most, I guess, like what's actually going to fit? So that, yeah, once we kind of get all the dimensions and all the research done, then we'll kind of have a better idea.
all right, thank you, Christian. I'm biased, but I'm really excited for this project. All right, next up is campus cleanup.
Hi, everybody. I'm the project leader for campus cleanup, and just to keep it quick, because unfortunately, due to all the issues going on, we haven't done much. So basically this year, our main goal was to go into Bailey Woods for the U of R students. One of the roads nearby our campus is Bailey Road. I know there's actually a U of R research laboratory, I think, on Bailey Road. But our main goal was to get in there and try to clean up as much waste as possible. Before you go to the next slide, Sarah, this picture on the left is just from last year's cleanup. So that was kind of what we were aiming towards to do again. We could go to the next slide. And this is just an overshot of the area. But due to COVID and a lot of the project members, including myself, were on co-op, we had a really bad lack of cooperation, not cooperation, but just people getting involved in general. It's a shame, but I mean, you can't do much about that with COVID going on right now. And I honestly was kind of happy because let's not try and get people contaminated. But fortunately, we were able to have a cleanup event nearby Perkins Woods. I wasn't able to make it since I'm out of town, but I know a couple members in the club were able to go. And next semester, once I'm back on campus, I hope to just pick this back up and continue to what we were doing last semester. You can go to the next slide. So really just to sum it up, right now the weather's also turning, so it's not really a great time to be getting out there. If anyone wants to get involved, and this isn't restricted to the RIT students, I mean, if U of R's remotely close, I mean, if you guys would like to get involved, feel free to email me, feel free to text me. We'd love more help. It'd just be beneficial to the ecosystems that are there. But that's mainly it for me. This is another picture of after we cleared the woods in that area from last year. So if anyone has any questions, feel free to ask. I know that was pretty quick, but I didn't have much else to say.
You didn't mention the most interesting thing. I personally think the most interesting thing that you guys have found.
I mean, we found a lot of interesting things. What are you talking about?
The car that's in there.
Oh, the car? Is that what you said? Sorry, you had
Yeah.
cut out. Yeah, so we had found, and I didn't put the picture of it, but we found basically half of a truck bed, and we found a couple front and back bumpers to cars, and I mean, we found a bunch of computers, tires, rims. We found a bag of bones, which was pretty strange. We found carpets. I don't know, you name it, we found it. We found a propane tank, which is kind of sad that you find that stuff and it's just left there. No one really picks it up, but I mean, that's the goal of this project, it's pretty simple, but at the end of the day, it does make a pretty big impact on our campus ecosystem.
Did not know you found a bag of bones. That is news
Yeah.
to me.
I think it was coyote. I think when we matched like the jaw to, which is strange. It really was strange. John was there. I think both Johns were there, right? But yeah, it was a weird time. But everything was taken to the dump, and all the scrap. We were trying to get the scrap metal to be brought to Metallico, which is just one of the nearby scrap metal places, but we were unable to. FMS just ended up taking it. We were going to use the funds to kind of put back into ESW, but they just ended up taking everything, which is fine. The garbage is gone, so that was the goal. Any other questions?
All right, awesome.
Thank
Thank you, Peter. So we have it's about 7:55. If anyone has any other questions, I'm gonna go back to the slides. This is the list of all the projects. If anyone has any questions, like this is the time.
I just wanted
know
to
we
make a
skipped over-
clarification. When I said the other project leader was Haritha, I actually meant Hania. I said the wrong name.
The record stands. I know we skipped over Inselnest, so I'm gonna go to them and see if it sparks any questions. Let me find it.
Yeah, I would love some questions.
Wrong one. Ooh, ooh. There we go.
I'd
Oh,
like
actually,
to
I
know
have
what you
some.
found the best design to be.
We know we found we don't know yet, but the biggest design you see right there, that's the simplest design right now. It's the easiest to manufacture. And we actually made a mock-up model resembling that. Yeah, so basically you make identical modules, identical layers, and with holes in them, but you offset them so the holes are isolated. It's kind of, yeah.
Are you going to be researching which one's easiest to manufacture as well?
Currently, we think that one is the easiest to manufacture, but yes, but that's like way down the line. We're currently just dealing with the material science so far.
Mm-hmm.
I was gonna ask, and I'm not sure. I hadn't thought of this before. Is there any worry about like allergies? Because you're dealing with a biomaterial, not like a manufactured thing. So I wonder if there's any worry about like
Yeah,
airborne biomaterials.
that's a legitimate worry, but I do think that this is a personal opinion, but I think that the chance of having or of like people being allergic to hemp or mycelium, that's going to be lower to people that have nut allergies. So it's not a huge concern.
Mhm. Also, to be fair, I mean, it's not like your fiberglass is not great to have in your body, and that's not usually an issue. So
Also, like this is like it's going to be between the wall facings. It's going to be inside of the wall. It's not going to be exposed.
Mhm.
Yeah.
So let's say the worst is the apocalypse happens, right? Will people be able to eat this insulation?
Yeah, people do make imitation meats or like vegetarian or vegan bacon out of mycelium. That's already been done. So you can technically eat this. I wouldn't, but you can. I guess it's edible.
The wood chips might cause indigestion, though.
Right.
I'm gonna go back to the slide. If anyone has questions for any of these groups. All right. I'm gonna stop the recording, and you guys are free to hang out or go or whatever you want to do. But thank you guys for coming, especially thank you U of R for presenting your stuff. I think it's always so cool to get a perspective on what other people are doing, because we're all kind of very stuck in our own projects. So I think this was really beneficial to everyone. So thank you guys so much.
It was our pleasure.
Thank you for having us.